So I'm Severin, and I work at Hinterling Volker as the head of interaction development, which kind of means that I'm the front-end guy. We are not a large company. And I'm going to talk to you today about Langstrasse, which is a project that we did about a bit more than a year ago, and which was quite successful in terms of awards. I guess that's why I'm here today. So, these are the topics I'm going to talk to you about today. It's about the video rendering, and then about preloading, image swapping and scaling generally, and some other random stuff. But maybe first, for those who don't know, I'm going to show quickly what this website is about. It's a website we made for Swiss television, documentary department, and they did a web documentary about the Langstrasse and the people who live and work at the Langstrasse, which is starts at guys who just opened a little hotel, or a prostitute, or a guy who makes tatuations. And they did a 5-part documentary about it, and came to us and asked for, well, you have to present it somehow on the web in an attractive way. And we actually got quite a bit of freedom to do that, which is really helpful when you do client work. That's what nowadays it's called parallax website, because you scroll like this, and as you can see, Safari has some buggy. The new Safari has some buggy behavior here, with these fixed elements here. But anyway, you can scroll through the Langstrasse like that, and you have some hotspots, like the tattoo studio, and then you can go into it. It's a common page reload. And then I have turned off flash, and this is a flash stuff. Well, it's with panorama stuff. There's 360 actually. And we didn't have a lot of time to do this website. It's only about 3 weeks, and so and it had to be Internet Explorer 7 had to be supported. So here we went with Flash, but the other stuff. This is a video with Flash fallback actually, and you can also scroll through it like video scroll. I'm not sure. And then you can see the questions, and the questions pop up, and he will answer them in the video. So yeah, that's basically it. Here you have a quick navigation on the side. Maybe I should show this in Chrome. Well, anyway, I hope you get it. Or should I show it in Chrome? Let's show it in Chrome. That's not how it's supposed to be. Here you can just directly jump to these hotspots, and if you would see a scroll bar on the right side, which is turned off here, you can see that these positions here, they actually fit to the scroll bar. Yeah, now you wonder why don't they fit? I can tell you. Because here, the screen is so small, and when I render those on the right side, I want to keep at least a little bit of distance between the items. So I don't just place them absolutely. I check whether there has been an item before, or navigation item before, and if yes, I keep at least a little bit of distance. So this is not a bar. Sorry. Now, first, how did we get to that? We have this inspiration. That's basically the only parallax site I didn't know back then. It's a NISO app. Probably most of you know it. And it's a very nice little website that promotes an iPhone app. And as you see, when you scroll like this, the items flow in. And that was the only parallax site I knew back then. There was this other one quite famous, this one, the Nike, which I didn't know about. So, during the concept design process, we came up with different ideas. One included a map as a main navigation, and then we came up with there's this Microsoft project that, what's it called again? Wait, huh? PhotoSync. Yeah, I guess. Where you can place photos, and then they will make up a panorama in front of you, and it was kind of this concept, and so on. And then that's when I saw this design. I came up with the idea to actually, if we have already a navigation on the right side that looks like that, why not use a scroll bar to do everything? And maybe why not use a video to actually go through the long street, to the Langstrasse? Because right here it was still this click, you click somewhere and then you go forward and you click somewhere and the next picture and so on. So yeah. The video was kind of an idea, and I started to prototype with the video and scrolling. And of course, I wanted to make use of the HTML5 video, which was not so common back then. It's not such a long time ago, but Chrome just supported it, and Safari too. And Firefox only had support for awk. And well, as you know, a video is not much more than just a series of images which will be played back. In HTML5 video object, you have a very easy way to access a certain frame of the video. It's just you just position the player. I mean, it's like video.player position equals the time. So it looked really good at the beginning with the video experiments I did, until I started doing it backwards. The normal way from the beginning to the end was really easy, but going backwards it seemed really slow and sluggish. And that's actually because videos are usually compressed by using keyframes, meaning that you have a keyframe, which is an image, fully compressed, and then the preceding frames are just the difference to the previous ones. So imagine, well, usually you have quite a lot of keyframes, like 20 or so. I mean, keyframe distances. And if you go here, if you access that frame randomly, what the decoder has to do, it has to go to the last keyframe and then calculate all the frames in between, the intermediate frames, up to the frame you want to see to calculate the actual picture. That wouldn't be such a big problem because you can just encode the video saying that you want a keyframe distance of 1 and have on every frame a keyframe. But then on the other hand you lose a lot of advantage about video, because all the compression enhancements you can get with these keyframe algorithms, with the whole H.264 compression, it's kind of goodbye. It's more or less like a JPEG compression then. And there's also this the thing that we don't have just one format for all browsers. We have back then it was just awk for Firefox. Now it's also WebM, and Google has announced that they will go for WebM only. They still support H.264 though right now. And Safari and Internet Explorer 9, they go with Epic 4, H.264. So,
sorry, could you say on the website button, because I always see people talking, so I suggest hast du nur noch die SF-Seite offen im Browser, weil da kommt die ganze Zeit der Ton von der Schnapsgeschichte, oder ist es von draußen? Das irritiert mich nur.
Ah, sorry. Dass ihr das hört?
Oder ist es von draußen?
Okay. No. So that's now a MPEG-4 video playing forward and backwards. I'm just doing always a player positioning. And this video here, this was encoded with keyframe, well, with keyframe distance. I don't know exactly, maybe 20 keyframes. Well, 20 in between. As you can see, it performs quite well, at least forward, but backwards it has some gaps. It has to do some more work, and if you would see the activity monitor, it also, the CPU goes up every time it has to go backwards, because if you, well, it's obvious, I'll explain that. Now, let's open the same in Chrome, and I made it so that the source for WebM and is first. I mean, this video tag takes sources, a number of sources, and then first took the WebM, so Chrome will go with WebM and not the H.264. And it's already forward, it's quite and backwards even more. It's not really the performance we're looking for. And now Firefox. It's the same. Firefox will go with awk. I mean, it could do the same with WebM now, but I took it before. Not really better. So let me just comment something out of here, because I want to show you how it looks with having a keyframe on every frame. I don't see. Yeah, you can see. Now you see it will go. No, it won't go. I have to take this up. Okay. Back to Safari. Fluently now. And also, you know, the activity monitor. Well, the activity monitor is high because I have something else open. But actually, I don't know, can you see this little icon here? It really doesn't use any CPU anymore now. And the same in Chrome again. It's better, but it still has little gaps, especially. And if you would do a random access of the frames, you would feel it even more, because now it's really one frame after the other, backwards, forward. But, when you scroll, you can scroll really fast. Some have mouses that take steps, like, I mean, you can skip a lot of frames. And in Firefox it's the same. It's just not as fluent as it should be, and it also takes a lot of CPU. And we want to do some other stuff, not just scroll through the Langstrasse. We also have some hotspots going down and some CSS transitions going on. So we don't need something in the background that uses like 300%, well, or 80% of all our CPU cores. So again, what are the positive points for video? Which is, it's quite kind of cool that it's hardware accelerated on many browsers, especially also the mobile browsers in the iPad or the iPhone. It's very easy to code. Just put the video tag in there and then set the playhead. It has quite a small memory footprint. It's quite efficient the way it handles the whole memory stuff. And you have an efficient compression when using keyframes. The negative points, though, well, I didn't mention that yet, but the interactive use on the mobile platform is quite limited. So on the iPhone, you always have this full screen video, and on the iPad you can actually put it on a website and put something on top of it, but you have to press the play button every time you want to start the video, even if you access it interactively. Then you have no control on the loading mechanism. This thing just loads linearly from the beginning to the end, so the first frame, the frame after the other frame. And if I go to this website, maybe I make a quick scroll to the bottom, and javoom, there is no street yet loaded, no picture at all. And you have slow access to these intermediate frames. Maybe it's not the right expression, but that's a punch in the face to the video. And that's why I decided to go with images. And I was hoping that the browsers would be performant enough to do that on their own, meaning by image swapping. Well, what do you need to do your own, to play back a video? It's you have to load the images, you have to render them, scale them properly, because we have this full screen, full window, and you have to swap the images. So I did a lot of experiments on them, on those things. And while I go one step after the other now, about first loading, you can just leave everything to the browser and access the frame on demand. So you go to frame 500 and you say, you assign the source to the image. That's of course not an option. It would be too slow. The other thing is you preload the whole stuff first, and then you get this nice preload animation in the beginning, because you have to wait until everything is loaded. I don't like that. That's what I did back in these days when I did Flash. And then that's what I came up with. It's I call it interlaced loading. It's not such a big deal, but it's a bit more complicated. Well, what I want to load like the first frame first, and then maybe the 100 frame, 100, 200, 300, 400, and so on. I have a demo now. It's very easy to see.
How many frames does your video have?
Sorry?
How many frames does the video on the site have?
It's about 1,000.
Okay.
1,100. So here I make just steps of 8. Yeah, I start with the first, and then 8 later, load it, then this, and now you don't see it. Small stuff. Well, and then I get to the end, and what I do is now I divide. No, not yet. I start at the index between 8, that means at 4, and I make these steps again until the end, and then the step is now divided by 2, and I make smaller steps to load in between. And then again, now I make steps of 2, until in the end everything is loaded. Now when I load a few frames like this, it's kind of crappy with this small screen. So let's load a few. Now let's say this is loaded, and I want to access a certain frame of the video. It just gives me back the closest that has been loaded. And if we would have a slow internet connection here, you could see it quite well, because in the beginning it's kind of, you have quite big steps when you scroll through, and then the longer you wait, the smoother the whole movement gets. Now, of course, I don't just have one loader. These are 4 or 8 concurrent loading like threads. You know, like you start one, and then when it's done, it waits actually a few milliseconds to give the browser some time to render also. And then it will just load the next, and so on. And if there are like 8 who do this, in the end, they will fill it up anyway. If I can have a little demo for that. Here we have a few more. And now when I start next, then it will automatically load the next one, like this. Da-da-da. Now I start a few more, and they will kind of see it maybe. Yeah, if you get that. Well, and this proved to be quite efficient, actually. It's, I think it's worth having not such a smooth video in the beginning, but instead really have immediate access to the website and not have to wait for, I mean, it's not such a big deal of content, so why do I have to wait like a minute before I can go somewhere?
How big is an individual image? You know, kilobytes?
An individual is, I would tell you, it's about 20, I think. Well, what I do is actually I take very small images for when I scroll through. And when I stop and I stay there for like 100 milliseconds, then I load a better version. And these are 12, yeah, between 10 and 20 kilobytes. I did actually a lot. I created a lot of images. And it's also the thing that you can take a bigger image and compress it, make a high compression, or make a small image and make not such a high compression, and you get the same file size, right? And more or less the same quality too. But and that's, for example, for retina displays, what you do is you take a bigger image and make very high compression, and it looks better to your eyes than take a smaller image and with higher quality. But here I went for small images, and the main reason is performance, because as we will see soon, the highest impact on performance actually is the image size. The smaller the images, the more performance you have. If you take this kind of image with a high compression, the loading performance is the same. It's 15 kilobytes, but whenever the browser has to render an image, it has to decompress it and then make an actual bitmap with a full depth out of it. That means a lot of memory swap, and it means a more decoding power. So for performance, small is much better. Some things I noted here is that Firefox has a surprisingly poor loading performance. I still wonder why that is. It's when you load images, maybe all the other stuff I didn't try, but it really kind of hogs the CPU, and that's why I had to make, before I started to load a new image, I had to make a higher time gap between timeout before I started the new load. It was like, let's see, it was really a lot more. Now, do you also like this new web inspect? I don't. Is it actually here? No, it's in another class. Wait, I really hate this. Yeah, not only Firefox, of course, also the Internet Explorer. I give them 50 milliseconds between the loads, and Safari and the other browsers, they can easily handle 5 milliseconds. That's just the time I want to give them to render while scrolling and when it's still loading.
Have you tried putting multiple frames into one image?
Sorry, multiple threads?
Frames into one image? Like a single JPEG?
Yeah.
Which has like 8,
Yeah, it's
16, whatever.
you need an even more decompression. I mean, you have even higher images, bigger images.
But fewer.
Yeah, but what would be the sense? You have only less. You have less requests, but the file size won't be smaller. So it's only about the requests. But then that's okay. Less requests is better, but the performance, the playback performance, would be smaller because each time you swap, well, not each time, but many times you swap, you have to make this deep decompression, decoding. And also it would be more of a pain to actually... yeah. Well, as I said, Internet Explorer has generally very low performance. Well, actually not generally. With the rendering it was quite fast. And with the iPad, and I think also the Internet Explorer 7, I wouldn't load all the 1,000 images. I would leave a gap of 2 because the memory footprint was just high for them. But actually for all iPads, for all iDevices. So now to rendering the images. There are a few methods I tried out. One is just put them all in the dome and set display non and block or inline, whatever you like. The other one is visibility. If you have visibility, you still have it in the render tree, but well, I expected a faster performance because you don't have to actually change the render tree of the browser. And the simple source assignment, as we all know it from a long time ago. Then setting a background image. And I first actually went with this one because you can use the background size cover, and then you have all this scaling done for you. But it wasn't very efficient, that I can say. It's actually if you take a background image and you don't scale it with the background size, then it's fine. But as soon as you start to scale it with the background size, it's not as efficient. And the canvas, you take a canvas and then you just draw the cached image into the canvas. And that's it. Well, and then performance-wise, I have, well, astonishingly, many of those methods perform equally, quite equally. Of course, display, if you look at the frames history in the inspector, you can see that if you set the display, you have a very little 0.01 millisecond of more work to do. But when you look, well, what I do with this kind of testing, I really look at how it performs, and you see no difference between display, visibility, background image and source. Canvas, I mean, on some browsers Canvas performs better, on others Canvas doesn't perform well, and on other beloved browsers we don't have support for Canvas anyway. And Well, what I went with is good old source. I just had the source of one image because I first it kind of felt better to only have one image in the dome, only one element for it. And then it seemed to perform quite well throughout all browsers. And also the memory handling of the browser was better. They kind of, if there wouldn't be enough memory, they can still kick an image out of the memory and just with display and visibility. I had actually crashes on the iPad 1, which is one of my favorite testing devices when it comes to performance. So, yeah, source was it. And now we have to not just swap the images, we also have to scale them up so they would fill the window. And here I also made some tests. The native scaling, you just adjust the width and height of the image. Some of them actually do it quite well, while most browsers are really efficient with images. They first, the WebKits, for example, they first make another anti-aliasing algorithm, and then only when they have a little time they render it better. But of course I expected that transform, what I was showing on the screen, transform 3D would be very nice on the iDevices and Safari. And nowadays it's also really nice in Chrome. 1 year ago, Chrome was really buggy with 3D. Well, it's still quite buggy, but on this one it works really well. So what I do is, whenever I can, I use the transform 3D. And otherwise, I go with native, because as you can see in Firefox, they kind of seem to treat it equally, whether it's transform 2D or native. I think they always use the same algorithm to scale these images up. Ah yeah, a little demo. Maybe you cannot see it. So, what I have here on the top is I can choose between those 5 rendering methods. I can say which image source it should take, the smaller image or the larger, and the scaling. Unfortunately, we don't have a big screen, it would be even better. And then the scale methods. So, maybe you will be able to see it. Now if we take the display and go through visibility, it's kind of the same. Now source. But it's not a really good computer actually for performance tests, because still it's quite a nice CPU. And but you will see that Canvas now in the recent WebKit, they performs really, really well, better than the other methods. Now I will go with a small image. Do you see the difference? Let's see here. Large, small, only with that. Let's go to yeah. It's too fast. On the iPad you would see it really well. Well, anyway, you will be able to see when I change the scale method. Transform, well now with Safari it doesn't matter anymore whether it's transformed 2D or 3D. It will render on the GPU anyway. That's a nice bar. Sometimes when I switch back to native. Native. I don't know if you can see it well or not. But there is a difference, especially with on the iPad. It's just huge difference whether you use the transform or native. Well, yeah, the biggest impact actually has the image size. You choose the source, how big it is. And I already told about that. Now, if we have time, some little random stuff. That's in parallax. What I would like to do actually in most parallax stuff, I would go on, I would keep it to the scroll bar and then change the position. I'll keep it to the main view and then just change the position from there, because then you don't have to do all the scrolling by yourself. But unfortunately there seems to be a sync issue on some browsers, especially Chrome last time I saw. Seems to have like, it first does the render when you scroll and then sends the event, the scroll event, and then only on the next animation frame your changes to the CSS will be rendered. So it's kind of, you scroll and it makes this strange moves. So I prefer to actually have those elements fixed and do all the positioning by myself. And it's quite fast if you use transforms and stuff. That's a small one when you often see these parallax sites where they have everything in one scroll event handler and do everything from there. And it's really a bad idea if you have everything in the scroll event handler, because then you're not able to do other stuff like on the iPad and the iPhone. When you do scrolling, you actually don't get any scroll event at all. So you have to do it in a different way. You have to listen to the touch move and request an animation frame and then render according to the actual position. And the little thing we have the street again. And we did this actually with on a motorbike. One guy on the back, one in front driving, and just that's why he also had to stop on the red lights. You can see it very good here. Here's the red light, and he had to stop. And then it goes on. And what was actually quite a lucky punch was that on this place we had quite a few hotspots we didn't know where they are before we started the project. Only towards the end they told us where they actually made these episodes. So it was really lucky that here I had some time to show some hotspots. And for others, like here, before that he had to stop, so I did cut it. And also on this one, but I kind of left it to here. What you can do is, let's go to hotspot. You can do is switch to night view. So they did the whole filming again in the night. That. And now you're more or less at the same place as the street. And of course, when they drove through the street in the night, the red lights were not the same as in daylight. Here they have green. You see, it switches to green now. So he didn't stop for me. And here it's the same, I think. Next red light here. It was yellow, but he went through. So it was kind of I thought, well, now how do I sync them when I switch between day and night? And what I did was actually quite easy, lazy. I just took these hotspots. Well, I know where in the movie the hotspots are, and I just interpolate between them. Like here I made an illustration where you can see it very well. Like at number 5 is later, and if I want to know where this is, I just interpolate on the day positions, and then I have more or less the right position between the day and the night view. I'm very much a fan of speed of performance, and I always try to tell our designers, please keep an eye on speed. And that's it. Thanks. Now, any questions left?
How do you deal with the 2 megabyte limit on the iPad?
Again?
You mentioned some stuff, but on iPad I think the limit is 2 megabyte for what you can use of memory.
The 2 megabyte, I think it's the browser cache when you switch to another page and back.
Like generally, how do you deal with image data on the iPad? Since the iPad is really
Well, I just loaded less images, but it can hold these. I'm not sure if it's 250 or 500 images, but it can hold it in the cache. I mean, not in the browser cache, but in the JavaScript memory. I don't care whether, well, I care, but it's not such a big deal whether when I switch to another page, it kicks it out of the browser. Of course, it's a bad thing. When you go back, it has to load again, more stuff, but it can deal. Somehow I just tested it, and
But did you have a lot of trouble with it?
if you have,
Did you have more trouble with the iPad than the desktop browser?
no, the iPad actually wasn't the requirement. I just did it because I like the iPad. The Internet Explorer 7 was a requirement, and that stuff I hated, yeah. Any more?
I noticed that the high resolution pictures are, you pixelated the faces. Did you reduce that?
Yeah, no, we gave it to somebody. I think it was somebody from Swiss Television who actually pixelated. And well, we actually got a call later because we forgot to pixelate one car number, And it was just on 2 frames, really small, and hello. I'm glad I didn't have to do that. Anything more? There's, if you're more interested about parallax, I didn't say a lot about parallax, but I made a tutorial on the Net magazine, and it's more about parallax stuff. I don't think it's nowadays so interesting anymore, if you consider how many parallax lights there are now. Okay.
Right, thanks.